A user says, "SSH accepted my key," then hung for 8 seconds before the prompt. Another says their automation broke because a new message appeared before the command output. Authentication worked in both cases. The problem lived after auth, in the login process. That space is where PAM opens sessions, banners and MOTD get printed, environment is assembled, last login information is shown, and finally your shell starts. If you administer Linux over SSH, this path explains a lot of SSH is broken tickets that are not authentication problems at all. The SSH login process on Linux is the handoff from this user proved identity to this user has an interactive or command session. OpenSSH handles the encrypted transport and the SSH authentication methods. On most Linux distributions, SSHD then calls PAM, pluggable authentication modules. PAM is not only passwords, it also has account checks and session setup. Session modules can create home directories, set limits, print messages, update login records, load environment variables, or start keyrings. After that, SSHD runs the user's configured shell, either as an interactive login shell or as a shell executing one remote command. Mechanically, picture SSHD as a parent process that accepts the connection, authenticates the user, then forks a child for the session. With use PAM enabled, SSHD asks PAM whether the account is currently allowed, expired password, disabled account, time rules, access rules, that kind of check. Then SSHD opens the PAM session. This is where PAM-env, PAM limits, PAM-MOTD, PAM Lastlog, and distribution-specific modules may run. SSHD also sets SSH client, SSH connection, SSHTTY, home, user, logname, and path. Then it changes to the user context and executes the shell from the account database. Only after shell startup files finish do you see the prompt. Walk these lines. First, SSHD-T prints the effective OpenSSH server configuration. The grep shows PAM, print, and banner-related settings after includes and defaults are applied. If SSHD is not in your path, use its full path, often under USR sbin. Second, inspect the PAM stack used specifically by SSHD. The exact modules vary by distribution, so read the file you actually run. Third, getent password shows your account record. The last field is the login shell SSHD will execute. Fourth, last reads recent login history, usually from WTMP. Fifth, Lastlog shows the last recorded login for that user, often from a sparse Lastlog database. Here is a common case. A team adds a compliance message and suddenly interactive users see 2 MOTDs while a deployment job starts failing because it expected clean command output. You check SSHD-T and see print MOTD enabled. Then you inspect pam.d SSHD and find PAM-MOTD also enabled. On Debian and Ubuntu systems, PAM commonly owns MOTD generation, including scripts under update motd.d. On other distributions, the pattern differs. The fix is not random commenting. Choose one owner for post-auth messages. Keep legal pre-auth text in the OpenSSH banner file if required. Keep operational MOTD short, stable, and post-auth. The first mistake is treating banners as harmless. The OpenSSH banner directive is pre-auth, so every connecting client can read it before logging in. That may be right for a legal notice, but do not publish host names, kernel versions, ticket queues, or internal contacts unless you want that information public. Second, do not trust client-sent environment variables. Acceptenv allows selected variables from the client, usually locale values. Permit user environment is off by default for a reason. Enabling it can affect forced commands and restricted workflows. Third, expect variation. Some systems use PAM for MRTD and Lastlog, some use SSHD options, and minimal containers may not maintain login databases at all. This episode sits between authentication and the user experience. Earlier foundation topics explain how the client reaches the server and how keys or passwords prove identity. This topic explains what happens after that proof succeeds. Next to it are shell startup files, sudo policy, and system logging, because many SSH problems are actually profile scripts, PAM modules, or audit records. For hardening, the login path matters because it is where limits, access controls, environment rules, and user visible notices take effect. For detection, Lastlog, journald, and auth logs give different views of the same session lifecycle. 5-minute lab on your own machine or VM. Use a system where you are allowed to administer SSH. First, SSH to localhost, and note what appears before the prompt. Banner, MOTD, last login, or nothing. Second, run the remote command shown on screen. It prints the shell name and sorted environment from a non-interactive command session. Compare that with an interactive login. Third, check last and last log. Did your localhost login appear? If not, you learned something about your distribution, container, or logging setup. Do not change policy yet. First, build the map of what your system actually does. 3 beats to keep. 1. Successful SSH authentication is not the end of login. It is the start of session setup. 2. On most Linux servers, PAM is the policy and plumbing layer that opens the session, sets limits, prints messages, and may update login records. 3. The user's shell and startup files finish the path to the prompt, while last and last log help you verify what happened. Tomorrow we keep building the foundation, one SSH topic at a time, moving from zero to expert. New SSH Mastery episode daily on this channel, alongside the daily ranked CVE brief for defenders.